Case 2 is where you have repeated linear factors in the denominator. So notice here, our denominator is x plus 1 cubed. That's a linear factor, but it's repeated because it's raised to the third power. And what you do in a situation like this is you break it up into three things in this case. Since that's x plus 1 to the third, I have to have a fraction for x plus 1 squared, and x plus 1 to the third. Like this. So whatever that power is, you have to go from, from the first power up to whatever this is here. Before we work this problem out though, let's look at the next example, because the next example is just asking us to work out the partial fraction decomposition. So write out the partial fraction decomposition for this. All right, for this we've got x, so we've just got an x there. X plus 2 is squared, so we're going to have x plus 2, and then we have x plus 2 squared, and then x plus 5. And we'll just go and string our letters across there. So that's the partial fraction decomposition for this thing. All right, now the power, the square here, is going to make things complicated, or well, it's going to complicate things a little bit for solving for those coefficients. Let's go back up here and look at this one. Same thing's going to happen here. The square and the cube, that's going to make things a little bit difficult, but not terribly so. So let's take this and multiply everything by x plus 1 cubed. When I do that, I get 2x plus 3 equals a times x plus 1 squared plus b times x plus 1 plus c times nothing, or times 1. All right. So if you look at this, if you want to use the technique where you plug in something that zeroes out the terms, the only thing we can plug in that'll zero things out is negative 1. So let's do that. Plug in negative 1. So on this side over here, we get negative 2 plus 3 is 1. And over here, this zeroes out and that zeroes out. So we're just left with 1 equals c. But now there's nothing left that we can plug in. So we've got to go back and look at the thing of setting the coefficients equal to each other. Now, let's multiply these things out. You got 2x plus 3 equals a times x squared plus 2x plus 1 plus b times x plus 1 plus c, but we already saw that c is equal to 1, so I'll go ahead and put that in here. All right, now you can just look at the coefficients and stuff here, but I think since we've only done a few of these so far, I want to actually multiply this out. This is going to be ax squared plus 2ax plus a plus bx plus b, then plus 1. So let's see. I want to sort this out by power. So I've got a times x squared. What do I have times x? Well, that and that. So I've got 2a plus b times x. And then what's left over, I've got a plus b plus 1. And that's equal to 2x plus 3. And on the front of this, I'm going to put 0x squared. So from over here, we can get three different equations. We could get 3 equals a plus b plus 1. 2 is equal to 2a plus b. And 0 is equal to a. Now, we really only need 2 of those equations. And let's see, the easiest ones here are going to be, this right here gives us a equals 0. And then we can pick another one. Let's use this. A plus b plus 1 equals 3. And what do we know? A is 0. So that gives me b is equal to 2. All right. So now that I've done this, I can rewrite my integral. I'm going to shrink it down so it'll all fit on the page. Or actually, I'll just disappear myself there. All right. So my integral becomes integral of, let's see, a was 0 over x plus 1. B is 2 over x plus 1 squared. And C is, what was C? C was 1 over x plus 1 cubed dx. And so now we've got to do this integral. And this integral is going to be not too bad to do. I mean, this first term, it's just 0, so we can ignore it. The other two, it might be tempting to pull a natural log out because that's what we've been doing on all these, but this is not a linear factor in the bottom. It's a linear factor raised to a power. So altogether, the bottom is not just a linear function. So what we've got to do is use the power rule. And I think the best thing to do here is just to do a u sub. If we let u equal x plus 1, du is just dx. So I can rewrite this as 2 u to the minus 2 plus u to the minus 3. And we can integrate that. This will be 2 u to the minus 1 over negative 1 plus u to the minus 2 over negative 2 plus c. Let's make that look a little nicer. Let's see, 2u to the minus 1 over negative 1. The 2 stays up top, u to the negative 1, and overall the thing's negative. Then the next one, we've got a 2 in the denominator, u squared in the denominator, and just a 1 on top. So the final answer is going to be minus 2 over x plus 1 minus 1 over 2 times x plus 1 plus c.